Good morning, students. So already discussed in the last class. So that topic is what is the vector product and properties of the vector product, and so what is the angular velocity, and so derive the equation for v is equal to r omega. Got it? So now today discuss the another problem by using the coordinates of the center of mass. Coordinates of the center of mass of the one dimensional and also two dimensional, also three dimensional. Now here taken, so general topic that taken is coordinates of the center of mass in a one dimensional. So center of mass of the two particles, center of mass of the two particles are in line one dimensional or x-axis or y-axis. Okay, that is taken two particles of a system. Two particles of a system. Center of mass of, okay, center of mass of the two particles of a system. Two particles of a system lying in one dimensional. In one dimensional. So that means only x-axis or only taken y-axis. So we can write that is taken x cm. Cm is nothing but center of mass. Okay, x cm, center of mass is equal m1 x1 plus m2 x2 by m1 plus m2. Okay, right. So what is the m1 and m2? So masses of the two particles or masses of the two bodies is taken, that is m1 and m2. So what is the x1 and x2? So these are positions. x1 and x2 are positions of the masses from the origin of the system. Okay, so we can write the formula. So x cm, cm means the center of mass. Okay, so center of mass is equal m1 x1 plus m2 x2 by m1 plus m2. So now we can write the n number of particles taken. So that taken, so plus dash of mn xn by, so the plus dash of plus n is taken, that is n particles in one dimension. Okay, n particles of a system in one dimension or one axis is taken. We can write, so m1 plus x1, m2 x2 plus etc. taken plus mn xn by m1 plus m2, so etc. mn. Got it? Now taken center of mass of the two particles. Center of the mass of the two particles of a system. Two particles of a system lying in a two-dimensional or xy plane. Two-dimensional or xy plane. Now taken two particles, center of mass of the two particles of a system in taken two-dimensional. So we can write the formula. So x cm is equal m1 x1 plus m2 x2. Okay, so plus dash of by m1 plus m2. Also we can write, so there is a xcm, we can write ycm is also, because taken x-axis and y-axis, that is the two-dimensional system. Okay, so m1 x1, now we have taken m1 y1 plus m2 y2 by m1 plus m2. m1 y1 plus m2 y2 by m1 plus m2. Now taken, if in case of the number of particles is taken, so here taken mn xn by mn. Here taken m n or y n or y n by m n. This is taken number of particles. Those similar pattern. Okay, so similar pattern also observed, that is the three-dimensional system. That is the here taken only one dimensional, two dimensional, three dimensional taken. So three dimensional taken, here taken xcm, ycm, zcm is also possible. Okay, so now we are taken in this problem only two-dimensional system. two-dimensional system, or that means x and y plane is taken. Okay, axis is taken. Now, okay, so what is the problem? So find out the center of mass. Find the center of mass of a three particles. Okay, center of mass of the three particles at the vertices of an equilateral triangle. Okay, vertices of a equilateral triangle. These masses of the particles are taken 100 grams, 150 grams and 200 grams respectively. Each side of the equilateral triangle is taken, that is 0.5 meters along the coordinates. Okay, along is taken. Right. So what is, now first of all, construct by triangle. Okay, so coordinate system is taken in a xy plane. So here taken, so this is called as a xy plane. Okay, xy axis is taken. Now is taken, that is the triangle. So triangle is taken, that is the equilateral triangle. That means equilateral triangle. So equilateral triangle is taken. Okay. So that are taken, so that is the coordinates respectively, so 0 and 0. So taken length 0.5 meters along each side of the triangle. So now taken 0.5 meters. Okay, so now here also 0.5 meters is taken. Now this is called as a O, A, B, okay, C is taken, and so taken angle is theta. Now here taken, so that is the 0.5 meters, 0.5 meters, 0.5 meters is taken equilateral triangle. Okay, equilateral triangle, so each one side is taken 0.5. Okay, so first of all, we construct the xy plane in a equilateral triangle of the coordinate systems respectively 0, 0 and so something is taken also and here also taken. So now first of all, here the coordinate system is taken 0, 0. Okay, so that is means x1 and y1. Okay, got it. So x1 and now the first of all is taken. So the masses of the three particles. So masses of the three particles is taken. So first one is taken 100 grams. Okay, 100 grams. So 100 grams. That is called as a M1. Now we have taken M2 body or M2 particle. That is equal to 150 grams. And here also M3 mass. That is equal to 200 grams. Got it? 200 grams. So M1 is equal to, that means given. So M1 is equal to 100 grams. M2 is equal to 150 grams. And similarly, M3 is equal to 200 grams are given. Okay. So now find out the by using the equation. So XCM is equal XCM is equal M1 x1 plus M2 x2 plus M3 x3 by M1 plus M2 plus M3. Okay. Now right. So YCM is taken. Okay. YCM, center of mass, is equal to M1 Y1 plus M2 Y2 plus M3 Y3. So by M1 plus M2 plus M3 is taken. Okay. So now already we know that is the masses of the three particles M1 and M2 and M3. But I will calculate it, that is the x1, x2, x3, y1, y2, y3. Okay, so x1, y1 is the at origin is taken 0, 0. Okay, so 0, 0. But here taken x2, y2 to find out the x2, y2. Okay, so x2, this is called as the x-axis. Okay, x-axis is taken, so this particle is taken, that is called as the M2 particle of the mass is 150 grams is the place. Okay, so now here taken, that is the length is taken 0.5 meters, that is called as the x2. Okay, so x2 0.5 on x-axis is 0.5. Okay, so y is taken 0 because only the particle is lying, or the mass of the particle is lying only on x-axis. Okay, so because y is 0. Okay, x is taken, x is on line, y is 0. Okay, y is on line, x is equal 0. Now we have taken x2, y2 is equal 0.5 and comma 0. Now also to find out the x3 and y3. So x3 and y3. Okay, so x3 means, so now we have taken x3. So this particle is taken here. Okay, so now to find out the x3, x is total is taken, so up to a point is taken 0.5 meters. So 0.5 is taken off of 0.25. Okay, so 0.5, so divided by 2. So is taken point, so 5 1 ja, 5 4 ja. So 4 into 1, 0. So 0. Okay, so 0.2 is called as a 825. So 0.25 is taken. So this is called as a midpoint. Okay, so total length is taken 0.5 meters and half is taken 0.25. So that is called as a x3. So x3 is equal to 0.25. Okay, so now find out the y3. So y3 find out by using the triangle. So OBC taken triangle. OBC triangle is taken. So sin theta is taken. So sin theta is equal. So sin theta is equal. So opposite side by hypotenuse. Opposite side by hypotenuse is taken. So opposite is BC. Okay. So BC by hypotenuse is taken OB. Okay, OB. So BC by OB is taken length already is given, that is the 0.5 meters. So sin theta. So this is called as a, now given the in a problem, so that is called as a equivalent triangle. So equivalent triangle is means so total is taken 180 degrees. Okay, so each one is taken 60. Okay, so 60 degrees. So sin 60 is taken. Sin 60 is equal to BC by 0.5. So sin 60 value root 3 by 2. So root 3 by 2 substituting is equal to BC by 0.5. So BC is equal to 0.5 into root 3 by 2. So cancel 0.25 root 3. Okay, so now is taken to find out the x3 and y3. So that is called as 0.25 root 3. Okay, so first of all, that is taken origin of the coordinate system 0, 0. Here taken x2 y2 is equal 0.50 and x3 y3 is equal 0.25 comma 0.25 root 3. Okay, so now substituting. Okay, so these values in the equation. So xcm is equal to m1 x1. Okay, m1 x1 means m1 is equal to already given, that is 100 grams. So 100 grams. xcm is equal. Okay, xcm is equal 100. Okay, 100 into x1. So x1 is equal to 0. 0 substituting plus m2. So m2 is taken mass of the body or particle 150, but y2. Okay, here taken y2. So y2 is equal to 0 plus m3 y3. So m3 y3. So m3 is taken. So mass of the body is 200 grams into y3. So y3 is taken, that is called as a 0.25 root 3. 0.25 root 3 by m1 plus m2 plus m3. So m1 is taken 100 grams plus 150 grams plus 200 grams. Now xcm is equal 100 into 0, 0. 150 into 0, 0. A remaining equation 200 into 0.25 under root 3. So 200 0.25 root 3 by 100 150 plus 200. So that is equal 450. Okay. So 0 0 are cancelled. Okay. So remaining equation is taken. So that is equal. Now taken M1, Y1 is taken. Okay. YCM. So YCM is equal M1, Y1. Okay. So that is taken. So 4 5. So 5 9 ja. So 5 4 ja. 5 4 ja is 20. 5 9 ja 45. Okay. So next one equation is taken. 4 into 0.25 root 3 by 9. Okay. 4 into 0.25 root 3 by 9. Okay. So 4 into 0.25 or multiplication is taken. So 0.25, 25 is into 4 ja is taken 100. Okay. So 100 is means root 3 by 9. Okay. Root 3 by 9. So root 3 by 9 and so divided and multiplication with respect to root 3. So root 3 3. So 3 by 9 root 3. So 3 1 3 ja. So 1 by 3 root 3. 1 by 3 root 3. Okay. That is equal. Only find out the YCM. So YCM is equal 1 by 3 root 3. Okay. So now find out the another. So that is equal as a, okay. So YCM. So to find out the YCM. So YCM. So now find out the XCM. Okay. So XCM is taken. So XCM is equal. So M1 X1. M1 is taken 100. Okay. 100 into X1. X1 is equal to, so 0. 0 substituting. Plus M2. M2 is equal 150 into X2. So X2 is taken 0.5. 0.5. So plus M3 X3. M3 X3 200. X3 is taken 0.25. Okay. By 450. Okay. Because taken that is 100 plus 150 plus 200 is equal 450. 100 into 0, 0. And 150 into 0.5. So 15 5s are. Okay. So 75 plus 225. 200 into 25 is 50. Okay. By 450. 75 plus 50. So 75 50. So 125 by 450. Okay. So total cancel. So that is called as a 5 by 18 is taken. Okay. So 25 5s are 25, 18s are 450 is equal 5 by 18. So now find out the XCM comma YCM is equal to 5 by 18 comma 1 by 3 root 3. So very important problem in IP. Okay. So first of all XCM find outing and YCM find outing. That is the coordinates. So that is called as a center of mass of the three particles. Center of the mass of the three particles. So XCM is equal equation and YCM is equal equation. M1, M2, M3 are three masses of the particles are given in a problem. That is 100 grams, 150, 200 grams. But to find out the X1, X2, X3, Y1, Y2, Y3. So substituting in the equation, we get the final equation XCM, YCM is equal. So this is called as a center of mass. Center of mass of the three particles XCM and YCM is equal 5 by 18 comma 1 by 3 root 3. Okay, got it. Now discuss the another topic is, so already we know that, so that is called as a angular velocity in your last class. So already derived the equation V is equal R omega. V is equal R omega. So now discuss the another topic. angular acceleration. Angular acceleration. Okay, angular acceleration. That is called as a alpha is equal d omega by dt. Okay, angular acceleration. Very important topic also in IP. Angular acceleration. What is the angular acceleration? Okay, what is the acceleration is nothing but, so velocity by time is called as a acceleration. Velocity by time is called as a acceleration. But here taken angular velocity. Angular velocity with respect to time is called as a angular acceleration. Okay, so we can write in mathematical form. So that is the alpha is equal to d omega by dt. What is the omega? Already we know that in your last class. So angular velocity. Angular velocity. So the rate of change of the angular velocity is called as a angular acceleration. Okay, so what is the momentum? Okay, so that is taken. What is the torque? Torque. So the torque is means. Okay, so change of the angular momentum dl by dt. Change of the angular momentum. Change of the angular momentum. The rate of change of angular momentum is called as a torque. So what is the angular acceleration? So change of the rate of change of angular velocity is called angular acceleration. It is denoted by the alpha is equal to d omega by dt. And also here taken torque. What is the torque? So the torque is nothing but is rate of change of the angular momentum is called as the torque. Okay, now first of all, so with the relation between, okay, these two definitions. Okay, the relation between angular acceleration and torque. So the relation between angular acceleration and torque. Now, so the torque, according to the definition of the torque, tau is equal dl by dt. But already we know that L is equal I omega. L is equal I omega. Already in last class, so that discussed the topic is V is equal R omega. Okay, V is equal R omega. Already similar pattern here also like that. L is equal I omega. I means moment of MI, moment of inertia. Omega means angular velocity. Okay, moment of inertia, angular velocity. Here taken L is called as a momentum. L is called as a momentum. In rotation method, by using the rotation, not a translation. Translation taken is I. I is means here in the rotational moment of inertia, but in a translation is taken, that is called as a mass. Here rotational angular velocity is taken, but in a translation only velocity, that is v. So the relation between is taken, torque tau is equal to dl by dt. So torque tau is equal dl. L means I omega. So I omega substitute in the equation by dt. So the torque tau is equal. So I is constant. So d omega by dt we can write. So now torque tau is equal to I d omega dt. Already to find out according to the definition, d omega by dt is equal alpha. So alpha value substituting in this equation. So we get the relation between torque and angular acceleration. So the tau is equal I alpha. Okay. So very important formula. And so IP 4 marks question. Okay, so that is the relation between, to find out the relation between torque and angular acceleration. So what is the definition of the angular acceleration? What is the torque? What is the relation between these two? So tau is equal I alpha. Okay, got it. So discuss the another problems in a next class. Okay, thank you friends.